but the original question has some more to it. So we only provided partial answer now. So the second part of the question is that the company has to have the highest rating. Okay. So highest rating, which software job belongs to a company with highest rating? So that's something that we can answer with what? Which of the operations that we have we can use to answer this question? Highest, maximum, minimum, sum, average. So all these, any aggregate function can be answered by what? Which function allow us to aggregate? Find a minimum, find a maximum, find a sum. Well, it's possible, for each is possible, but we want a function that is shorter and faster. Reduce, okay? Reduce. Now, if you use for, you can obviously use for each, but you have to do more work. All right. Okay, so how do we use the reduce in order to answer this question? Now, first of all, let's prepare the callback function. So the callback function that we need to send here is the reducer or the combine function. Okay, so let me just call it max rating reducer. Now the name reducer is just a word I added to the name just to remind you that this is a reduce function, but it's not necessary. Okay, so this is a function. I'm gonna start with the longer form. Okay, now the reducer takes how many arguments? So a function that we send to reduce, we oftentimes call it combine or reduce, and it takes how many arguments? 2 arguments. So the way it reduces, the reduce function, the way it reduces, it takes 2 arguments, apply the operation, find the result, right? Take that result and take the next element in the array and apply the operation on them, right? And then take the result of that and apply the operation on the result and the next element in the array. All right, so it reduces 2 by 2. All right, so the first argument that we send to the reducer is supposed to work as the accumulator. Okay, so we can call it result, we can call it accumulator, you can call it, I'm just gonna call it something really relevant here, so I'm just gonna call it previous maximum. All right, the second argument that we send to the reducer is what? It's supposed to be the element that will when the iteration happens, it will send one element at a time in the array. All right, so that would be the current job. Okay, so the first iteration will have, now the first iteration will have the first element as the previous and then the second element as the current. Second iteration will take the next element as a current, and then it keeps moving like this. Okay, so the iteration iterates over this current job. All right. Okay, so what is it that we need to return here? We are looking for the maximum. So it depends on whether the previous was bigger than the current. Okay, we just every time or every iteration we will return the bigger of the two. Okay, so we need to ask a question. It can be an if statement, it can be any conditional in any conditional structure. So I'm just gonna use the ternary operator because it's just one line. Okay, so if the previous elements dot job rating Okay, the job rating of the previous element, or the company rating of the previous element, smaller than the rating of the current job. Okay, so that's the question that we need to ask. If this is true, then the previous maximum should not be the maximum anymore. The current should be the maximum, right? So if this is true, then we return what? The current job. All right. If this is false, what do we return? The previous maximum remains the maximum, and that's the one that we need to return. Yep. Okay, yes.
So the question marks in time is basically saying after you do this like logical statement, it's true, you return the first one, false, you return the second one.
Yes. So it's like if else, yeah. It's exactly like the if else. So this would be the part in the condition part.
Yeah.
And this would be in the true block. And this would be in the else block. Okay. All right, so now we prepared the reducer. Now let's see which array we want to work with. Now we don't want to work with the original array. We want to work with the one that has the software jobs only. Oh dear. All right. So this is the one I want to filter. I want to reduce. And the result of the reduce, the way we defined it, it returns one element, right? So this would be let found job. So this should be the answer of our last question, or the entire question. Okay, so we can send it the function here, or we can use the error notation if we want. Okay, now we already know how to use it. So I'm not gonna repeat it. You can try different ways when you practice. What is going on? All right, so let's just print that found job to see how does it look like. All right, so we can see that it has a rating of 5, and the rating 5 is the maximum, but there is something else here, is that it has only 2 reviewers. So 2 reviewers give it the maximum rating, so that's not very reliable. So let's say I wanted to add another filter or another criteria to only select the jobs that has 100 reviews. Okay, so this way the rating would be more reliable. So I can just add a condition here to this to the original predicate. I can do that. Or if I wanted to be flexible, I can create another filter. Software jobs with 100 ratings that takes that array and filter it. So it will take a job and return whether this job dot. No, I can't use the dot notation because the name of the property has space in it. Okay, so how do I refer to a property that has space in its name? Using the square brackets. Okay, so it returns whether the rating is bigger than or equal to 100. Okay, so if I print this should be even less. All right, so no, it should be less than that, more than or equal to. Oh, yeah, that's right. All right. There you go. So now we have 73. Now, instead of applying this, the reducer on the software jobs, I want to apply it on the one with the 100 reviews. All right, so now we have another 100. It has less rating, but it has 600, so it's more reliable. Okay, now last thing before we go, there is it's just a style called chaining that you might see. Instead of having applying the operations or the analysis operations like this with intermediate storage, okay, there are some advantage in using this intermediate storage. Is that if you need to debug it, or if you need the intermediate step for other reasons, then that would be good. But if there is a problem with the memory, you want to reduce the usage of the memory as much as you can, or you just want to have a more condensed coding, you can do that chaining thing. So we have the original array that we applied a filter on it, right? So instead of having the filter, the result stored, I'm just gonna apply the next operation directly on what returns. So this should have the exact same effect. So when I add the dots here, it will be applied on the array that returns. See what's happening here? So this function returns an array, right? So I'm just saying dot. So this dot is just applying this operation on the array that returns. Okay? And then I can add another to the chain, okay? And then this should give me the same result. Okay, and if I try to print it, it should give me the exact same result. All right. Okay, even Victor still, you may find some people use this chain in multiple lines like this. No, in JavaScript, the empty spaces doesn't mean anything. So this is just a matter of formatting for readability. Okay, so having them in one line or multiple lines like this, doesn't matter, it's exactly the same. Okay, so now that should, so when you see this, some people get confused when you see this syntax. It's just a matter of formatting for readability. All right, so that's all we have.